This is Josh White from JW Math Tutoring. Today's video, I'm going to cover the 6 hardest problems from the February 2025 ACT Math section, Form Z14. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Just before I begin this video, going through these 6 hardest ACT problems from this test, I just want to mention a couple things. First, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, the reason I'm only highlighting 6 problems from this test is because I've gotten hit with copyright strikes from the ACT when I published full reviews of completed official tests. So that's the reason why you only see 6 problems instead of the full 60, which I would love to do, full videos on. Lastly, if you're looking for more ACT practice work, please check out my Improve Your ACT Math Score course. You can find it on Udemy. You can find it also on Teachable. There are direct links to both courses in the description of this video below. And basically, this is a comprehensive overview of the math section on the ACT. It covers your common topics in algebra and geometry and probability and statistics, in addition to strategies like back solving, picking numbers, process of elimination, estimation, drawing a picture, essentially in order to help you solve problems as quickly as possible. And it also includes an entire module on using the TI-84 graphing calculator to solve problems as well. Basically, it features over 10 hours of instructional video along those 5 different modules. So please do check that out. Anyways, here are the solutions to these 6 hardest problems. This video, I'm going to go through the 6 hardest problems from the February 2025 test, Form Z14. So, first one I'm going to take a look at is question number 42. This problem, as you read it, might seem a little bit difficult or a little bit confusing. However, there are 2 things you can keep in mind as you go through this. First, the theoretical way to figure this problem out is to note that over here, where the pizza is cut into 6 pieces, these are going to have the largest slices, whereas over here on the right, where it's cut into 9 pieces, these are going to have the smallest slices. So you want as many of the largest and as few as the smallest. So if a person's going to have 5 slices total, and having eaten at least 3 different kinds of pizza, you want basically, you want the 3 kinds of pizza to be from here through here, and you want as many of the largest possible and as few from the smallest possible. So it's going to be 1 here, and then the other 3 are going to be from here. And so that's going to be 3/6 plus 1/7 because there are 7 pieces for this second one, and then 1/8 because there are 8 pieces for this third one. So the correct answer to this problem is letter K. Now the other way that you could figure this out is you could go ahead and basically add up all the values for these expressions, for these fractions. I won't spend the time doing it here, but I'll just tell you, basically f comes out to 0.601, g comes out to 0.656, h comes out to 0.712, j comes out to 0.744, k comes out to 0.767. Okay, so obviously k is the largest expression, showing for the amount of pizza one person could have eaten. So then all you need to do is just basically look and see, is this scenario possible? If you eat 3 pieces from the 6-piece pizza, 1 from the 7, 1 from the 8, is that individual eating 3 different kinds of pizza? Yes. Is that individual eating 5 total slices of pizza? Yes. Therefore, since it's the largest number and it meets both those criteria, it's going to be the correct answer. Okay, let's look at the next one now that I have picked out, and it is question number 47. It's basically a rate, time, and distance problem, but it's got some unit conversions mixed in as well. All right, so basically what we have is a car is accelerating from 0 to 60 in 15 seconds, and then it averages, and its average over that period is 30 miles per hour. And then it maintains this constant speed at 60 miles an hour for the next 15 seconds. What fraction of a mile has the car traveled? Okay, in those 30 seconds. All right, so we know the basic formula, right? Rate times time equals distance. So now, what we're going to do is look at the two parts of the trip. So for the first part, we know that the average speed is 30 miles per hour, so we're going to use that. So that's our rate. So 30 miles per hour. And then we would multiply that by the time. That's the rate. We're going to multiply it by the time, which is 15 seconds. Now, here's the problem. The rate is miles per hour, but the time is in seconds. So we have basically different units. So what I have to do now is convert 30 miles per hour just into miles per second. So the way I'm going to do that, so first let me just put the hours down here. Let me just erase. You can just keep the miles up there. All right, so now we have to multiply, and we're basically going to have to say 1 hour 3,600 seconds. Now, you could also technically do 1 hour, 60 minutes, and then times 60 minutes, 1 minute, 60 seconds, if you don't know that an hour has 3,600 seconds. But in any case, now the seconds will cancel out and the hours will cancel out, so we can just multiply everything across here. It's going to be 30 times 15 divided by 3,600. So I'm just going to go to the calculator to do that. And this will be the distance for the first 15 seconds of the trip. Notice it's 0.125, or if I just go here to the math menu, convert it to a fraction, it is 1/8 of a mile. Okay, so right off the bat, I mean, we know that A is going to be wrong because it obviously also travels some distance for the second part. So the second part, everything's going to be the same. Now it's going to be 60 miles per hour. Again, times 15 seconds, and again, times the same unit conversion of 1 hour, 3,600 seconds. So notice these units cancel out. Also notice this is just going to be double that, because notice 60 is double 30. So this is technically going to work out to be 2/8 of a mile. But if you want to go to the graphing calculator and just multiply it out, that's fine. Second entry, so we can pull the whole thing up again here, and then just go over here, change this to a 6. Yep, see it's 0.25. Now that's technically one. It's giving us 1/4, the simplified version of the fraction instead of 2/8. But now we can just add these two together. What fraction of a mile has the car covered in these 2 seconds? Well, 1/8 plus 2/8. Add them together. That's just going to be 3/8 of a mile. The correct answer here is letter C. And you could just add. So actually, here we could take our answer, then we could add it to it's not letting me copy down the whole thing, whatever. I'll just add it to 1/8, or we could just type the decimal. Okay, it's 0.3785, math, fraction 1, there it is, 3/8. Okay, so that's how we could do this question. This is number 47. Next up, I want to take a look at 49 here. Now this one, there are actually 3 different ways you could do it. One way, which actually is the quickest way, is to note that tangent is equal to sine over cosine. So if you rearrange this, you get cosine is equal to sine over tangent, or in other words, 1/2 over negative root 3 over 3. So you could do this on the graphing calculator, or if you, I'm just going to show it to you by hand. 1/2, and then it's divided by this, which means when we do state change flip, it's the flip is going to cause the 3 to go to the top and the negative root 3 to go to the bottom. So we get negative 3 over 2 and a root 3 on the bottom. Now that doesn't match any of the answers, so let's do this. Root 3. We get negative 3 root 3 over, on the bottom, this becomes 3. 2 times 3 is 6. And of course, we could simplify it. 3 goes into 6 2 times. The answer should be negative root 3 over 2, letter B. That is the correct answer. So that's what we're going to choose. So that's one method to solve this. But if you don't recognize that, that's fine. Another method would be to draw a triangle. I would start with the sine part, and I would notice sine is equal to opposite over hypotenuse. If you notice, this is going to just be a 30, 60, 90 triangle, but if you didn't know that, you could also do, 1 squared plus b squared equals 2 squared, b squared equals 4 minus 1, b squared equals 3, b equals the square root of 3. And now you could do the cosine of this angle, which is just going to be adjacent over hypotenuse, root 3 over 2. However, here is the one thing that you must remember and must keep in mind. It's basically the, this ASTC thing. The sine is positive. That means we are in quadrant 1 or quadrant 2. But the tangent is negative. That means we are in quadrant 2 or quadrant 4. So therefore, quadrant 2 is the only one where the sine is positive and the tangent's negative. Therefore, the cosine will also be negative. Cosine's only positive in quadrant 1 and quadrant 4. So you have to remember to go ahead and put this, put the negative sign in front, because this is technically a quadrant 2 angle, even though the way I drew it, it looks like a quadrant 1 angle. All right. Next thing to keep in mind is third way you could do it, which is just using the graphing calculator entirely. So let me just, hold on, clear this out. So all you could do is, first let me just make sure I'm in degree mode. I am. All right. So you could just solve for the angle. In other words, I could do the arc sine of 0.5, which is just 1/2. So notice it tells me it's a 30-degree angle. Then I could do the cosine of that. Now, what you're going to have to do is you're going to have to see which of these expressions this matches, and more importantly, you're going to have to remember that the answer is going to be negative. Because it's going to be in quadrant 2, you would have to again remember that the answer is going to be a negative value because cosine's negative there. So right off the bat, you could eliminate these. So then you're down to 3 choices to check. So if you don't recognize it already, you could just type each of them in and see which is equivalent to this. So for example, square root 3 divided by 2. Yep, it matches. So that just confirms that B is the correct answer. But that's an alternate way. That's the third way that you could solve this problem as well. All right, next, let's take a look at number 55. So in this problem, you have this square, and it's split into a bunch of triangles. And let's see, we're told that BC, CD, and DE. So this, all the same. And then F and G split the other side such that all 3 of these are the same. This, and this are all the same. So how many of these triangles, basically 1, 2, 3, 4, 5, have the same area as AGH? Okay. So AGH, of course, is this one right here. Okay. So it turns out the correct answer to this one is E. It's all 5. The reason is because they all have a height which is the same value. So first of all, because this is a square, like basically this side, and this side are the same. So when you look at like for example, for triangles 1, 2, and 3, the height is just AB. For 4, 5, and AGH, the height is just the side AH. But these are equal because it's a square, because in a square, all four sides have the same length. Then the base are all congruent because there's 3 congruent parts on each side. And since you divide them up evenly, they're all the same. Like, say each side is 6, this would be 2, 2, and 2. Well, if this is a square, this is also 6. So this would be 2, 2, and 2. So each of the individual bases, HG, GF, FE, EDE, CD, BC, they're all the same. They're all 2, so they all have the same base. Therefore, they're all going to have the same area. And just to confirm, like this distance right here, this is the height for these obtuse triangles that you see, because remember, the way you draw it, the height is the perpendicular distance between the vertex and the side that you're declaring as the base. So this distance right here, even though it's not in the triangle, this is the height, for triangle AFG and AEF. And then this distance right here is still the height for ACD and ADE. Therefore, the correct answer is E. It's 5. They all have the same area as AGH. And that's it for this problem. All right, next up, let's take a look at 58. So I wanted to mention this one just to talk a little bit about ellipses and hyperbolas, since they seem to be coming up a little bit more. So basically, a couple things. First, in order to have the same asymptotes, you must have the same number under the x squared and y squared term. So you need an answer that has a 9 under an x squared and a 4 under the y squared. So that's the first thing you have to look at right off the bat. So G is out because it doesn't have that. H is out, it doesn't have that. And J is out, doesn't have that. So you're down to these two choices. The other thing to keep in mind is a hyperbola always has one positive term and one negative term. So the correct answer for this one is K. F, excuse me, not A, F, the first answer, this is actually an equation of an ellipse because of the plus sign that's in the middle. So just like H also is an ellipse as well. So if you want to start eliminating that, using that fact initially, you could do that as well. But the plus sign in the middle with the two different numbers on the bottom makes it an ellipse. The minus sign with two different numbers on the bottom makes it a hyperbola. And to get the same asymptotes, because when you basically go to graph it out, you move so many left and so many right and so many up and so many down, and then you draw a little box, and then you basically draw asymptotes through the corners of the box. Ignore the there. That's what it should look something like that. To get the same asymptotes, you need the same value under the x squared term and the y squared term. The fact that the x squared term is first means that the given problem opens left and right, whereas in the answer choice that's equivalent with the asymptotes, letter K, it would open up and down. That's basically the difference between the two. All right, last question. Let's look at 59 here. This is a fairly difficult question, although there is basically you can use a strategy of picking numbers to attack it. So, a couple things here. Here, first I'll show the theoretical approach to it, then I'll show the actual numerical calculation. The mode is obviously going to be C, which is the one that has the highest frequency, right? So I'm just going to pick some numbers, like just say these are, it's 8 consecutive positive integers, so I'm just going to call them 1 through 8, right? So the mode is obviously C or 3. If you add up these frequencies, basically 1, 3, 4, we're up to 8. 8 plus 3 is 11. 11 plus 2 is 13. 14, 15, 16. Okay, there's 16 total values in our data set. That means the median will be the average of the 8th and 9th value. So the 8th value would be, let's see, 1 plus 3 is 4. 4 plus 4 is 8. 8 plus 1 is 9. It's basically going to be the average of the C, which is the 8th value, and then the 9th value is in the D column. So the average of C plus D divided by 2. So notice that is going to be to the right of C. And again, if you want to use picking numbers, you'd use 3 plus 4 and you get 7, and then 7 divided by 2 is obviously 3.5. Okay, so now, basically, we know that the mode is less than the median. So let's see here. If there's anything comparing, the median is less than the mode. So you can eliminate B. That second half of that is wrong. That doesn't say anything about median and mode. That doesn't. The median is equal to the mode. Okay, so E is wrong too. So right off the bat, we can get rid of A, C, and D. Now, with the mean, basically, because you have these, like, they're not really outliers, but because this thing has these values over here on the right, whereas like almost everything else is sort of uniformly distributed between A and E, these three values over here are going to pull the mean or the average up higher than the median. So the mean is going to be higher than the median. And again, the reason is because of these three values that are over here to the right. Like, that's the theoretical approach behind this. Therefore, another way to think of this is just the median is less than the mean. So the correct answer for this one is going to be A. Mode less than median, median less than mean. Now, if you wanted to actually calculate it out just to confirm this, basically, here's what you could do on the calculator. You just multiply the numbers by the frequencies, right? So 1 is the value, and the frequency is 1. So we got 1, and then plus 2 is 3 is 6. 3 plus 4 is 12. 4 plus 3 is another 12. 5 times 2 is 10, and then 7 plus 8. One of each of those. All right, so now I'll just go to the calculator. Let's add these all up and divide by 16 and see what we get. Again, you could, of course, do this in your head, if you wanted to. All right, so I get 56. Did I miss something here? There should be 1, 2, 12, 12, 10. Oh, I missed a 6 in here. 1, 2, 3, 4, 5, 6, 7, 8. Yes, there should be 8 total values. They should add up to 62. That's why I thought something's wrong. Because when I did it previously, I got 62. So the total is 62. We divide that by the number of values, which is 16. And let's see what we get for the mean. We get 3.875. All right, so notice the mean is greater than the median, which is 3.5. Or another way to think of it is the median, 3.5, is less than the mean, 3.875. Therefore, the answer has to be A. C is obviously wrong for a variety of reasons. The mean is not less than the median, and also the mode and the mean are not equal. That's only going to be true in a true normal distribution, where things are distributed evenly on either side of the middle. And in 10, the mode is less than the mean. That is true. 3 is less than 3.875. The mean is equal to the median. No, they are not equal. The mean is greater than it. So correct answer to this is just going to be letter A. If you enjoyed this video, if you have any questions or comments on these problems, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And of course, as I mentioned earlier, check out my Improve Your ACT Math Score course if you're looking for more resources to help raise that ACT math score of yours.